So we'll look at some inequalities now. Inequalities mean that they're not equal, so they're things that don't have equal signs in them. The first thing we need to understand is that if we have brackets like this, that means that we're talking about less than or equal to or greater than or equal to. It means that the ends are included. If we have parentheses, it means we're talking about just less than or greater than. It means that that end is not included. Okay, so let's just practice graphing some basic interval notation problems just so we can see how we're going to be writing our answers. So you can see in this first problem, the left-hand side has a bracket. That means that that is included, that -2. But the right-hand side has a parenthesis. That means that the 5 is not included, so it's going to go up to like 4.9999, but not 5. So here's how we show it. On a number line, we want to be able to start at -2, and then it would be -1, 0, 1, 2, 3, 4, 5. And this -2, because it comes first, means we're starting at -2, and we're going to put a bracket there to show that that -2 is included. And then we're going to shade that line until we get to 5. And at 5, we're stopping because of the parenthesis. Now, I know we just said 5 is not included, right? It's going to go to 4.999, but we don't have a real good way of showing that other than putting a parenthesis at 5 and shading up to that parenthesis. So that's how that graph looks. A bracket at -2, parenthesis at 5, shading in between. Let's do another one. So here we want to go from 1 to 3.5. So we'd have 1 as our first mark, 2, 3, 4. There's a bracket at 1, and then it goes to 3.5, so I'd put a bracket halfway in between 3 and 4. And it's telling us, this tells us we start at 1, we end at 3.5. So we'd shade everything in between. We'll look at one more. This goes from -infinity to -1. Okay, so -infinity is the arrow that goes forever, keeps on going in the negative direction. So that's this side. And we'd shade until we get to -1. And at -1, there's a parenthesis because we're not including -1. Now, infinities, positive infinity or negative infinity, always have parentheses because you can never reach that number. It's not a number, it just keeps going. Remember that when you're solving an inequality, that you have to switch the sign when you multiply or divide by a negative number. That's the only difference really between solving an inequality and an equation, is that when you have a negative number, when you multiply or divide by a negative number, you have to switch the sign. So let's look at this problem here. Okay, so here's where our inequality sign is. The first thing we'll do is subtract 2 from both sides. So we get -3x is less than or equal to 3. And then we're dividing by -3. So when we're dividing by a negative number, we have to change that sign. It's going to become greater than or equal to instead of less than or equal to. So it leaves us with x is greater than or equal to -1. So that's one way of writing our answer. Now the problem says solve and graph on a number line. So let's look at our graph on a number line. This says that we have -1, and this is opening to the x. That means we need x's that are going to be bigger than -1. Well, bigger means to the right. and it's just going to keep going to the right. And then this said or equal to, so we want to put a bracket at -1 showing that we're including -1. So that's our graph. Now we can write this answer in interval notation by reading the graph from left to right. So we start here, that's the first spot we hit on our graph. So we'd have bracket, -1, comma, and then it goes forever in the positive direction, so that would be positive infinity, and then infinities always have parentheses. So that is another way of writing our answer. Here's another problem to practice with. Let me write it a little bigger. 3x plus 1 is greater than 7x minus 15. Here's our inequality sign. Oh, plus 1. So the first thing I like to do is move my x's to the left. So I would subtract 7x from both sides. And that gives me -4x plus 1 is greater than -15. Then I'd subtract 1 from both sides. -4x is greater than -16. And then I divide, but I'm dividing by a -4, which means this has to change sign. So it's going to go this direction instead. So then x is less than 4. So on a number line, I'd mark my 4, and then it opens, the sign opens to the 4. That means 4 is biggest. It's like that mouth eating the bigger number. So x's have to be smaller, which means it would go this direction from that 4. It's just less than, which means we have to put a parenthesis at 4. And then to do interval notation, we would start by reading that graph from left to right. And the first thing we see from left to right is the arrow in the negative infinity direction. So we'd write negative infinity with a parenthesis, because infinities always have parentheses. And then we go to 4, and that's where it ends on the right with a parenthesis. Let's look at the next problem. So in part A, we'll do the same sort of thing. Again, just like when we had equations, we need to get rid of those parentheses first. So we'll distribute the 3, and we get 3x plus 3 is greater than 3x plus 2. So first thing we would do is subtract 3x from both sides. But you notice it cancels out on both sides, which is a little weird when we get 3 is greater than 2. And 3 is always greater than 2. There's no x in there, which means that any x in the world that we wanted would work in this problem. So it would be everything, the whole entire graph, because any x you stick into this problem is going to make it true, because 3 is always bigger than 2, I mean. So negative infinity to positive infinity, everything in the world will make that problem true. Let's look at this one. So here I'd start by subtracting x from both sides, and I get 1 is less than or equal to -1. Now 1 is not smaller than -1, and it will never be smaller than -1. And because there's no x in this problem, it means that this is never going to be true. So this is a no solution. Okay. In section 1.2, at the very beginning, we talked about 3 types of equations. This part A is an identity because it's always true. But part B is inconsistent because it's never true. So here you can see that we have 2 inequality signs. We're going to solve this the same way as the others. Let me write it out so it's bigger. So I have a line here and a line here because that's where our symbols are. We're trying to get x by itself here in the middle. So the first thing we need to do is deal with that plus 3. So we're going to subtract 3, but when we do it there, we're also going to do it here and here. So I'll cancel that out in the middle. On the left-hand side, we have 1 minus 3, which is negative 2. Keep that symbol. 2x in the center. And then on the right-hand side, 11 minus 3 is 8. Now we're still trying to get x by itself, so we need to divide by 2. We're dividing by a positive 2, so it does not change the signs. It's just a regular division. So negative 2 divided by 2 is negative 1. This is an x here in the middle. And then 8 divided by 2 is 4. So this is saying that we want x's that are between negative 1 and 4. So if we look at a number line, we would have negative 1. You can mark 0, 1, 2, 3, and then 4. At negative 1, there's a bracket. It's included because of that equal sign. But at 4, that's just strictly less than, so we have a parenthesis. And then because x is between, we shade in between. Now we can write that as an interval notation by reading it from left to right. The first thing we see on the left is the negative 1 with the bracket. And then it goes until we hit 4 with a parenthesis. So that's our answer. Now we can also deal with absolute value inequalities. So this works a lot the same as equations that we did in the last section. The first thing we have to do with an absolute value inequality is to get the absolute value by itself, just like we did with equations. So here's our equal sign or inequality sign. We'll start by subtracting 20 from both sides. And that gives us negative 3. Remember, this is times 5x minus 2 is greater than or equal to negative 39. And then we need to divide by negative 3. And remember, when we're dividing by a negative number, that changes that symbol. So we get absolute value of 5x minus 2 is less than or equal to 13. Now that the absolute value is by itself, we need to write out two smaller equations. So we'll have 5x minus 2 is less than or equal to 13. When we write out the other one, remember we changed this sign, but when we have inequalities, we also have to change this sign. We have to change two things when we write out our other problem. So our second problem will be 5x minus 2 is greater than or equal to negative 13. So we'll solve this top one first by adding 2 to both sides. So then we get 5x is less than or equal to 15. Divide both sides by 5. It's a positive 5, so it doesn't change the symbol. So we just get x is less than or equal to 3. And we'll come back to that in just a second. Let's deal with this other problem down here. So we'll start by adding 2 to both sides. That gives us 5x is greater than or equal to negative 11. Divide both sides by 5. It's a positive 5. So we get x is greater than or equal to negative 11 fifths. So we need to put those two answers together on our number line. So we have negative 11 fifths, which is somewhere over here on the negative side. And then we have positive 3, which is somewhere over here on the right-hand side. This is saying x is bigger than negative 11 fifths. So bigger than would go to the right of that. And then x is smaller than 3, so that would go to the left. And both of them have the equal to, so we'd have brackets at both ends. So that would be our graph. So to write it in interval notation, we start reading from the left-hand side. So we would write bracket negative 11 fifths. And then it goes to 3 on the right-hand side. So we have 3 and then another bracket. That's our answer. Now in the homework, a lot of times it will ask for this answer before the graph. But if you do it on your paper with the graph first, it makes it easier to write this interval notation. So I always do the graph before I try to write that answer. Let's look at one more. So here, the absolute value part is already by itself. So we're going to write our two equations. So if 18 is less than 6 minus 3x. Remember, the first one we copied just without the absolute value signs. And the second one we changed two things. So we'd have negative 18 is greater than 6 minus 3x. We changed this and we changed this. So we'll start by solving this one first. I would subtract 6 from both sides first to get it away from the x. So 18 minus 6 is 12. And then I need to divide by negative 3. Because I'm dividing by a negative number, I need to change that sign. So that gives me negative 4 is greater than x. A lot of times we like to write the x on the left-hand side. That's okay to do that, but if we do that, we have to read it backwards. And that we have to keep the symbol opening to the negative 4. So if we write the x first and then the negative 4, we have to make sure that when we rewrite it, we keep the symbol opening to negative 4. So let's do the same thing over here. We'll start by subtracting 6 from both sides. So that gives me negative 24 is greater than or equal to negative 3x. And then I'm dividing by a negative 3, so that means this gets changed because it's a negative number. And that leaves me with 8 is less than or equal to x. Again, I can rewrite it, but this time it has to stay opening to the x. Okay, let's put that on a number line. So we have negative 4 and we have 8. This is saying x is smaller than negative 4. So smaller than negative 4, we need to go this way. And it's just less than, so it would have a parenthesis. Now I messed up. This symbol right here doesn't have an equal underneath it. So when I wrote it over here, it shouldn't have an equal underneath it either. Sorry about that. So when we do this piece on the right hand side, this says x is bigger than 8. So bigger than 8 would go this direction. Again, there's no line underneath. There shouldn't be a line underneath. So we have a parenthesis here and it goes on for forever this way. So when we write our interval notation, we read from left to right. So the first thing we encounter is this arrow going into the negative infinity direction. So we'd have negative infinity with a parenthesis. And then we hit negative 4. And there's a parenthesis there. And then we have a whole separate piece over here on the right, which starts with 8. And then it goes forever in the positive infinity direction. And the way we write those two pieces is we just put a U between them, and that kind of glues the two pieces together as one answer.